All right, guys. So I had a little phone malfunction, so I apologize. So part three of the video is kind of at an awkward transition here, but we're gonna pick it up about where we left off. So proving isosceles trapezoids in the coordinate plane. Step one is really proving that it's a trapezoid, period, not an isosceles trapezoid. So when we use the slope formula to prove that one pair of opposite sides is parallel, usually I'll graph the figure first. I'll try to pick the pair that by the eye test is most likely to be parallel. I'll test that. Now, if it's parallel, we can move on to step two. If it's not parallel, we do have to check the other pair of opposite sides just to see maybe they're parallel. Maybe my graph didn't look perfect and I misjudged. So you gotta check both pairs of opposite sides until you get one match. Otherwise, it's not a trapezoid. You can just stop. But once we get one pair of opposite sides parallel, we know it's a trapezoid. We're going to take the other pair of opposite sides and we're going to run the distance formula on them to see if it's an isosceles trapezoid or not. If the other pair of opposite sides, if they are congruent to each other, then we have an isosceles trapezoid. If they're not, then we just have a regular trapezoid. All right, so looking at the speaker problem here. So they tell us right away that F, J, H, and they're naming them with three letters because these diagonals kind of ruined calling it J. But anyways, F, J, H is 85 degrees. Now we're looking for F, G, H. Now they tell us it's an isosceles trapezoid, so whatever F, G, H is worth, J, F, G is going to be worth the same. Or we could think of it as, whatever FJH is, GHJ is going to be worth the same. So that angle right there is also going to be 85. Either way, we know that angles that run along a leg are going to be supplementary. So we take 180 and subtract 85, and that's going to tell us that FGH is going to be 95 degrees there. So both vertex F and G would have 95 degrees there, each. All right, so next we're going after KH, which is part of the diagonal FH. It's from the intersection of the diagonals all the way to the the vertex down here. Now we're given that FK is 8. They tell us that JG is 19. Now if this is an isosceles trapezoid, it's going to have congruent diagonals. So that tells us right there that FH is also worth 19. So this goes back to kind of the the segment addition postulate from earlier in the year where 8 plus KH is going to be equal to 19. Basically, we're just subtracting 8 from 19 to figure out that KH is 11. Looking at the isosceles trapezoid problem down here, looks like we got some lunch trays there. So hopefully you guys will be back throwing some spicy chicken sandwiches on those soon. Anyways, in the given information here, they tell us that angle YZW, so YZW, okay, so vertex Z is worth 45 degrees. They tell us that WV from this vertex to the intersection of the diagonals is 15. They tell us the rest of the diagonal VY is going to be worth 10. So we know the diagonals are worth 25 total each. And they want us to find each of these measures. So starting off, we have XWZ. So it looks like that's the other base angle. So, vertex W and vertex Z are going to have the same amount of degrees there, with this being an isosceles trapezoid. So that angle is also going to be 45 degrees. Now, next we have WXY. And that would technically be vertex X right there. So we know it's going to be supplementary with vertex W. So we take 180, subtract 45, and there's going to be 135 degrees there for vertex X, which is angle WXY. From there, they want XZ. Well, we know the diagonals are congruent to each other, so if WY is 15 plus 10, 25, then XZ is also going to be 25. Finally, we have XV. I talked about that we have a pair of isosceles triangles here. So if we have 10 right here, we're going to have 10 right there, and same thing with 15 here and 15 here. So XV is going to be worth 10, length of 10 there. All right, so the next page 16. Here we have the proving an isosceles trapezoid on the coordinate plane. So looking at my graph, it didn't look like AB and DC are going to be parallel. There's a chance that AD and BC are. So I'm going to start off by taking their slopes. Slope of BC ends up being -2. Slope of AD ends up being -2. So we do have one pair of opposite parallel sides. So the shape is a trapezoid. We know that. So now we need to investigate whether AB and DC are congruent or not. If they are congruent, it's an isosceles trapezoid. If they're not congruent, it's just going to be, your average trapezoid. All right, so taking the distance of both. For AB, I ended up getting the square root of 26. For DC, I ended up getting the square root of 25. So when you run the distance formula, it's close, but they're technically not congruent. So in this case, it is a trapezoid because BC is parallel to AD, but it is not an isosceles trapezoid because the legs AB and DC are not congruent. All right, so looking at the next page, we got the mid segments of a trapezoid. So looks like my diagram there didn't print out, so let's just make one real quick. So I'm going to draw a trapezoid. Now the mid segment is going to be connecting the midpoint of each leg of a trapezoid, so something like that. So we have our mid segment right here.